Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. Today we will learn about the data structure, arrays in the Python language. Let's continue with the chapter on arrays. Today we will learn about historical data references for arrays. Let's go to our strategy editing page. If we want to reference some historical data, we can use the following example for test. First, we declare a variable a. Then we use the function arrayNewFloat to initialize it. Then we use the function arraySet. We use the function arraySet to set the 0th index element of the array. Set the elements of the array A with index 0 to close using the close built-in variable. Here we declare a variable close AE, A1. Use the function arrayGet to obtain array A. And the index is 0 here. Then we use the historical operator to reference it forward with brackets. We declare another variable close B1. We use the ordinary built-in variable to reference it historically. Also reference it a period forward here. That is, reference the previous closing price of the K-line bar. We use the function plot to draw close A1. Name it as close A1. Set the color as red here. And set the size of the line as 6. Then we draw close B1. Name it as close B1. Set the color as black here. And to demonstrate the effect, let's draw close B1 a bit finer. Set the size of the line as 2 here. Then we click Backtest. Here we can see the thicker red line and the thinner black line are identical and the values are exactly the same. It proves that the two methods are exactly equivalent when we are doing historical data references and direct references to built-in variables. If we use the elements of the array as the data in the function to calculate the index, is the reference the same? Let's continue with the above code and write. We declare a variable ma1. Representing an average line here. Then we use the function tasma, pass in array get, including array A and element index 0. Then we calculate the average line with a period of 20 here. Then we declare a variable ma2. Use the function tasma2. And we pass in the built-in variable close here. And calculate the average line with a period of 22. We use the plot function to draw them respectively. First, we draw ma1, name it as ma1 here. And set the color as aqua. The size as 6 here. Then we draw ma2, name it as ma2. Set the color as black here. The size as 2. Then we click backtest. And we can see that the red line is close A1 here and close B1. And the equal line is MA1 and MA2 here. There is no way to calculate the average indicator before 20 periods. All here is no data. It is all NA. When the average indicator can be calculated, there is a data displayed, and we can see the lines of MA1 and MA2 calculated are completely overlapping. That's to say, the two ways are equivalent. There are also some manipulation functions in the array, such as functions for adding and deleting, array unshift, array insert, array push. All of these functions will be used in our strategy to process the array. Here let's demonstrate the specific functions of these functions in details. We declare a variable a, then we use the function array_from to initialize it. Let it contain 3 elements here. We write 3 strings A, B, C. If we want to test the function array and shift, we can declare a variable ret. The function array and shift here is operation on an array. The first function is to manipulate the array, adding an element to the first position of the array. Here we add x. Then we use the function runtime log to print it out. That is what the specific return value of function array and shift is. Finally, we use the runtime log function to let it stop. Runtime error function here. We click backtest. In the log message column, we can see that it printed out a piece of data in the log message column. After we call the function unshift, it inserts a new element called xString at the position of the first element in front of the index of the array A. That is, we write in the function to insert an xString. Unshift has no valid return value, that is, the return value is null. It only works by modifying the original array and inserting a new element at the beginning. So this is the use of the unshift function. Let's go back to the code page to continue testing. Again, we use the variable ret. Test the insert function. The insert function means to insert a new element into the array at a certain index position literally. Here we insert a new element at index 1. We insert the string y here. Then we use the function runtime log to print the original array A out. We can copy this line and paste it. We use the runtime log function to print the original array A, and then we observe the return value. Click backtest. We can see that the second call is to call the insert function after calling the unshift function, and then it inserts a new element y here at index position 1. After the previous statement modification, the array of A becomes x, A, B, C, and then adds a new element y to the array element index position 1, and the array A becomes x, y, A, B, C, and its return value is also null here. Let's go back to the code page. We continue to test the function push. Again, we use the variable ret to receive return value. Array push. We use the function array push to add a new element to the end of the array. Here we add a string d. Then we use the function runtime log to print it out. Click backtest. We can see that the original array is changed again by adding a new element d at the end, which also returns a null value here. Let's go back to the code page. The above three functions are all array adding functions. Then we will learn the usage of the delete function for arrays. The first one, we use the function remove. Here we use the variable ret to receive the return value. The first parameter is the array we want to manipulate. Here we remove the element with index of 2 from the array A. Then we use the function runtime log to print it out. We click backtest. We can see that we have removed an element with index position 2. The previous element with index position 2 is the string A. After we removed it, the array A becomes x, y, b, c, d. So here we removed the element A. Besides this, we can also use the function array shift to remove the first element of the array. We use it to remove the first element of array A. Then we use the function runtime log to print it out to see the result. We click backtest. we can see that the array becomes y, b, c, d after we removed the first element x, and it returns to x here. Besides this, we can also use the function array pop to remove the last element of the array. We continue to write array pop. And use the runtime log function to print it out to see the specific return value of the function. We click backtest. We can see that the array becomes y, b, c after we remove the last element d here, and it returns to d. If we want to clear the entire array, we can use the function array clear. Again, we use the variable ret. And print it out. We click backtest. We can see that the array becomes an empty array in the log message column, and it returns to null here. We can construct a queue data structure by using arrays and some functions of adding and deleting arrays. Queues can be used to calculate the moving average of tick prices. Someone may ask, why should we construct a queue structure? Didn't we use arrays to calculate the average before? In fact, a queue is a structure that is often used in the field of programming. The characteristic of a queue is the element that enters the queue first leaves the queue first. This ensures that the data in the queue is the latest data and that the length of the queue will not expand indefinitely. And we need to pay attention to whether there are excessive references, application resources, use of resources, etc. When writing the strategy, because no matter what device, memory is certainly limited. And if arrays of variables data structures are infinitely inflated, it will certainly cause a problem. If we want to construct a tick level moving average, then we can write the strategy like this. We write a strategy, name it as test. And let it draw on the main chart. Then we use the var IP keyword to declare a variable a. Use the function arrayNewFloat to initialize it to 0. Then we declare a variable length. And initialize it to 10 here. Oh, don't forget the var keyword. Var length, let it be 10 here. We use the if not bar state is history to execute when it is on the real-time bar. Then we use the function array push. And write array A, pass in the built-in variable close. Then we continue to judge when the length of the array more than length. We use the array shift function to delete the first element of the array. In this way, we have constructed a queue data structure. The length of this queue is 10, and then it will keep pushing new data into it. After the data length reaches 10, it deletes the first one, then the second and the third one, continually. This creates a queue structure that is always length. If we use here on backtest page, we use the tick model. The data will increase fast. Let's continue with our code. We declare sum. And initialize it to 0.0 here. That is, it's a type of floating point. Then we use the for loop to iterate through the array A. Let all the elements accumulate to sum. That is a sum of tick level. Then we calculate the average price, declare average price here. We use the function array size to judge whether the length of the array is 10 elements. Then we calculate the average value. Divide the length by sum. Let it return to NA when the condition is not met. Then we use the plot function to draw the average price out. Name it as average price. And we draw the TASMA for comparison. Use the plot function as the above. Passing close. Length. And TASMA. In this way, we can observe the difference between the printed tick level averages and the 1 minute period averages or fixed period averages. In our backtest page, we choose this configuration here. Set the end time at 20 minutes. Apply it. Set the K-line period as 1 minute and the execution model to tick model here, so that the strategy executes the strategy code once for each price change during the real-time K-line bar stage. We click Backtest. And we can see that the average can only be calculated during the real-time bar, because during the historical K-line bar stage, each K-line bar only goes once. As we can see, we have 1 minute average. Because this chart is a 1 minute period K-line chart, the yellow line here is the 1 minute period average, and the purple line here is the tick-by-tick average, which means that every price change is collected together, and then the averages of the tick level changes are calculated, and we can see that they are different. The above is the application of the queue structure in the writing strategy. In the queue structure, we use the push function, shift function. Through the combination of these functions, we can not only construct the data structure of the queue, but also construct the stack data structure. Other common array calculation and manipulation functions can be found in our API documentations here. We can click the PyScript documentation and find them in the contents, such as average, sum, the standard deviation, and so on. Let's go back to our code page. We write an example for testing. We declare a variable a here. We use the array from to initialize it. Here we initial a set of numbers here. 3, 2, 1, 5, 6, 7, 8, 9. If we want to calculate the average of all the elements in this array, we can use the function runtime log directly. Call the function array avg. Pass in a here. And don't forget to use the function runtime error to let it stop. We click backtest. We can see that the calculated average is 5 here. That is, the mean value of all the elements added together is 5. So let's move to the next function. Go back to the code page. If we want to find the minimum value in an array, we can use the function runtime log to print out the minimum value. We pass in a as 0. Click backtest. And we can see in the log message column, the minimum value printed out is 1 here. And if we want to print out the maximum value, we can use the runtime log function as the above. Change it to maximum. Click backtest. Okay, in the log message column, we can see the maximum value printed out is 9 here. If we want to calculate the standard deviation of a set of data, we can use the function runtime log to print it out. Change it as we click backtest. We can see it printed out the calculated standard deviation is 2.5 5, 8, 1, and so on. Besides, the summation operation of arrays is the one we use the most. In fact, we have used it in our previous courses. Here we change it as sum. Okay, we click backtest. We can see that the calculated sum is 45 here. These are commonly used array calculation functions. In addition, there are also functions that can be used to manipulate arrays, such as array splitting, array conversions, etc. Here we perform a demonstration. We declare a variable a, initialize it with array from, assign an array with the elements 2, 3, 4, 5, 6. Then we declare a variable b, assign an array with the elements 11, 2, 13, 4, 15, 6. We use the function runtime error to let it stop here. Oh, don't forget to print the original array. And the array B, we first print it with the runtime log function. We print the original array and the array B. Then we use the function runtime log to print the arrays A and B. Use the array concat function to add the arrays A and B together. Concat function here. A concat B. We click backtest. We can see that the original array A is 1, 2, 3, 4, 5, 6, and the array B is 11, 2, 13, 4, 15, 6. And here it becomes two arrays connected after splitting them together. In this way, we can clearly see that this function is concatenating two arrays together. Let's go back to the code page. Here we create a new array C. Copy it here. We copy part of the array B to C and assign it to C. Use the runtime log function to print it out. Then we click backtest. We can see that we copied the array B. The value of the array C is exactly the same as the array B. Let's move to the function array join. It can concatenate all the elements of an array by characters and return to a string at the end. Here we write an example for test. We concatenate all the array C with a plus sign and use the function runtime log to print it out. Here we concatenate all the array C with the plus sign here. We click backtest. Oh, it reports an error. Let's go back to the code page to check it. We lost half of the. Let's click backtest again. You can see that the result is that each element of the array C is concatenated with a plus sign to form a string at the end. And we often use sort when processing arrays or writing strategies. If we want to sort the size of the array, we use the function array sort. Here we use it to sort the array. Arrange the arrays B in order from smallest to largest. Use the runtime log function. Array sort B order. We use ascending here, the function order ascending. That is, we arrange the array B in order from smallest to largest. We click backtest. Okay, we can see that after sorting the array B, it becomes such a smallest to largest order here, 2, 4, 6, 11, and so on. Let's go back to the code page. If we want to sort from the largest to smallest one. We just change the function to descending. Here we copy and paste it. Change it to descending here. Click Backtest. And we can see it sorted by descending order 15, 13, 11, 6, and so on. After the sort function, let's move to the reverse function. How to reverse the order of all the elements of the current array order? We use the function arrayReverse. Here we pass in the parameter a to invert the array A. And use the function runtime log to print it out. We click Backtest. And we can see that A becomes 6, 5, 4, 3, 2, 1 here. That is, all the elements have been reversed. Then let's see the function arraySlice. It can slice the array, intercept a section of the array and return. If we want to slice the array A, we can use the function runtime log. Here we intercept the stage of index 0 to 6. We need to note that the beginning index and the ending index are specified in such a way that the specified range follows the left close the right interval row. That is what we specified contains the index 0, but not index 3. In fact, it intercepts to the position of index 2. We click Backtest. Oh, it reports an error. Click Backtest again. We can see that the intercept element does not contain the element with index 3. It only intercepts to the element with index 2, that is, it only intercepts the three elements with index 0, 1, 2, and returns them as fragments. We can also operate on arrays to perform searches. If we want to search for an element in an array, we can use the function array includes. Here we search for the element 11 in the array B. We click backtest. And we can see that the includes returns the true value. That is, the search array B has the element of 11. If it cannot be searched, it will return to false. Let's try it. Go back to the code page. Here we search for 100 in the array A. As we know, there is no 100 element in array A. It will return to false. We just try it. We change it to A and 100. Click backtest. You can see that it returns false here because there is no 100 in the array A. So that's all for the functions we have taught about today. If you have any questions in the process of writing the strategy, you can check the API documentation here on our FMZ platform, and some of them include the examples for learning. So that's all for today's lesson. If you think our video tutorials useful, don't forget to like, follow, and repost. Your support is our greatest motivation. Thank you all and see you next time.